In this video, we're going to be talking about how you find the volume of rectangular prisms. So let's go ahead and open this up. And first of all, just what is volume? Well, volume is the amount of space inside a three-dimensional figure. So when you first start talking about geometric things, like you usually start with perimeter. And perimeter is like the distance around a figure. And then you learn about area, and area is the number of squares it takes to cover something. The volume is what it takes to fill something up. It's the number of cubes, these little cubes, that would fit inside something. All right, so this is called volume. It's the volume of the figure. And volume, we just talked about it, is measured in cubic units. They want to know how much cubes of a certain side, or how many cubes of a certain side fit inside. This tells you the number of cubes of a given size it will take to fill the prism. All right, so then this would be an example of a rectangular prism. You can tell it's rectangular because all the sides are rectangles, right? And a prism is just consistently the same shape throughout the figure. All right, so anywhere we slice this figure, we would get a rectangle. All right, so the volume of a rectangular prism is the product of its length, width, and height. And you've probably seen this before. You may have looked at it as volume is equal to length times width times height. If you use the abbreviations, the letters for those, L times W times H. All right, so if you want to figure out how many cubes fill up the inside of this, you would multiply the length times the width times the height. And this is not difficult to do, but it's not the only type of prism. And so as you get closer to geometry and as you get closer to 7th and 8th grade, you're going to learn that there are other shapes that you need to be able to find the volume of. Well, as long as it's a prism, then there is a formula that kind of works for everything, but it is not known as length times width times height. That only works for rectangles. So they've switched the formula that they give you on the star chart. You're not going to see the volume listed like this anymore, right? It's going to look like this. It's going to be a capital B times H. So the H part is still the same. It's the height of the prism. But that capital B, what that stands for is the area of the base. It's this part down here. All right, so if I find the area of that and then I multiply by how tall it is, that will also tell me the volume. And that's handy because depending on the shape of the prism, that will always work. If I know the area of the base and then I multiply it to just how tall it is, then I can find the volume of lots of different things. All right, but they go ahead and switch the formula first before they teach you about those other shapes. All right, so you can multiply the area of the base, and look, it's going to be a capital B, so that's different than the base we've seen in formulas like for triangle and trapezoids, by the height, which is H, to find the volume, which is V. Okay, so in the first example, it says determine the volume of the rectangular prism. So I'm going to show you how you can do it both ways. Now, if you just know the volume is length times width times height, for rectangular prisms, you are welcome to use that formula. But if you don't remember that, then what you're going to find when you look it up is this right here. So you also need to understand what this is, what that V means. All right, so length times width times height. If I apply it to this prism right here, the length, the width, and the height, it really doesn't matter which is which. I'm going to multiply 10 times 5 times 2. All right, and then I can multiply 2 at a time. 10 times 5 is 50. 50 times 2 is 100. The volume is 100. And then see that I've changed the exponent now to a 3 because I'm measuring in cubic feet now instead of square feet, like with area. All right, so for the area, for the volume of a prism using this formula, that B, that capital B, means first find the area of the base. All right, well, the area of a rectangle, right, is base times height. So really the area of this rectangle is 10 times 5. And then I'm going to multiply by how tall it is, which is 2. All right, so 10 times 5 is 50. 50 times 2 is still 100. The volume is 100 cubic feet. All right, so I haven't really changed anything with rectangles, but I have to understand this formula here. In the first exercise, we're determining the volume. And I'm going to go ahead and use length times width times height because it's something you're already familiar with. So I'm going to be multiplying 2 times 3 times 4. So I can multiply 2 times 3, that's 6, and 6 times 4 equals 24. I'm measuring this in feet cubed. Now, if I want to talk about this formula right here, then the first thing I need to figure out is the base part. Okay, what's the area of this part right here? Well, that would be 4 times 2, right? Because that's where the 2 comes from. So I could find the area here. 2 times 4 is 8, and then times the height would be 3. I'm still going to get the same answer. All right, and this next one, length times width times height, I'm going to be multiplying 4 times 4 times 4. This is a cube. 4 times 4 is 16. Then I need to multiply that times 4. So 16 times 4, 24, carry 2 is 64. So my volume is 64. It's in cubic inches. All right, again, I can find the area of this down here. So this would be 4 times 4 right here, and then times how tall it is would be 4. 16 times 4 is still 64. Number 3, all right, volume is length times width times height. So again, multiplying 20 times 5 times 5. 20 times 5, you're not sure what that is, multiply it. It's 100, and I still need to do 100 times 5, which would be 500. This is in cubic yards. So volume is equal to 500 cubic yards. Again, if I'm using this formula, the area of the base times the height, then the base is this rectangle down here. What is the area of that base? It's 5 times how long is this piece right here? 20. I get that from right there. And then how tall is the prism? 5. So I'm still doing the same thing. 5 times 20 is still 100 times 5 is still going to be 500, right? Still in cubic yards. All right, and the last example is still going to be length times width times height. So I'm going to do 5.4 times 3.2 times, I think that's a 9, yeah, 1.9. All right, so using some decimals this time, just be careful keeping track of your decimals. So I'm going to multiply 5.4 times 3.2. 2 times 4 is 8, 2 times 5 is 10, start with a 0. 3 times 4 is 12, carry your 1. 3 times 5 is 15, plus 1 is 16. Add these up, 1728. There are 2 decimals here, so 2 decimals here, 17.28. That's these 2 numbers, so I still need to multiply times 1.9, so 17.28 times 1.9. 9 times 8 is 72, carry your 7. 9 times 2 is 18, plus 7 is 25, carry your 2. 9 times 7 is 63, plus 2 is 65, carry your 6. 9 times 1 is 9, plus 6 is 15. Start with a 0. 1 times 8 is 8, 1 times 2 is 2, 1 times 7 is 7, 1 times 1 is 1. Add these up. I get 2, 13, carry your 1, 8, 12, and 3. There are 1, 2, 3 decimal places here. That puts my decimal between the 2 and the 8. So the volume is going to be 32.832 cubic centimeters. All right, so again, if I'm looking at the area of the base times the height, then I need to find the area of this rectangle here. So what would you do? You would multiply 5.4 times 3.2, which is exactly what I did here. Then I would multiply times the height, which was 1.9, which is what I did here. So same exact answer. All right, so again, you can just remember this formula because you've used it before, or if it's something you don't already know and you want to be able to look it up on your chart, then this is what you're going to see, but you're going to have to understand that B is an area, okay? It's not a base like we used in our area formulas. All right, so that's volume. Thanks.